You know, all the healthcare we get, all the treatments and advice, it all comes from research. But have you ever stopped to think about who is actually in those studies? How do researchers decide who to pick? That's what we're diving into today. It's a process called sampling, and it's this incredibly important method of choosing a small group to represent a much, much larger one. And trust me, getting it right is everything for the evidence that modern nursing is built on.
So here's what we've got on tap. First, we'll tackle the big picture. What even is sampling? Then we'll get to a major fork in the road, the two main paths a researcher can take. We'll explore path 1, probability sampling, and then path 2, non-probability sampling. And to wrap it all up, we'll hit the key takeaway that'll help you make sense of pretty much any study you come across.
All right, let's jump right in. We're starting with the big picture, and that means looking at this huge problem that every single researcher runs into when they're trying to answer a big question.
Okay, so it sounds simple, right? If you want to study the habits of nurses, why not just ask all of them? But I mean, really think about that. Could you actually survey every single nurse in the entire country? No way. The cost would be insane, it would take forever, and you'd never even find them all. It's just impossible. And that's exactly the problem sampling is here to solve.
And this is where the magic happens. Sampling is the answer. It's basically the science of picking a smaller, representative group, that's your sample, out of a giant group, the population. The whole point is to make this sample like a perfect miniature version of the big group. That way, whatever you learn from your small sample, you can be pretty confident it's true for everyone else too.
Think of it kind of like a funnel. At the top, you've got the huge entire population you're interested in, let's say all nurses. Then you narrow it down to a target population, maybe just ICU nurses. Then you narrow it again to the accessible population, the nurses you can actually get in touch with. And only then, from that much smaller reachable group, do you finally pick your sample. This whole funneling process is what makes these huge studies even doable.
Okay, so once a researcher knows they need a sample, they come to this big fork in the road. They have to make a choice between two totally different ways of doing things. It's a huge decision for their study.
So, on one path, you've got probability sampling. This is the random one. Think of it like a lottery, where every single person has the exact same chance of being chosen. This gives the results some serious statistical muscle. The other path? That's non-probability sampling. Here, it's not random. People are picked for a reason, usually because it's convenient or the researcher uses their best judgment. It's all about what's practical. So, let's walk down each of these paths.
All right, first up, path number 1. We're talking about what's often called the gold standard, especially in research that deals with a lot of numbers. This is probability sampling, and it's where things get really rigorous and mathematical.
The absolute key idea here is randomness. Everybody in the group has to have an equal shot at being picked. This is huge because it removes bias. The researcher can't, even by accident, pick their favorite people. And because of that randomness, they can confidently say, hey, what we found in our small sample, it probably holds true for the entire population.
So under this big umbrella of probability sampling, there are 4 main ways to do it. You'll see these a lot in really solid research. Let's do a quick breakdown of each.
First off, you've got simple random sampling. This is the most basic, purest version you can get. It's literally like putting everyone's name into a giant hat or a computer program and just pulling out names completely at random. That's it. Every single person had the exact same chance to be chosen. Super simple and really, really good at avoiding bias. Okay, next up is systematic random sampling. This one's a little more structured. You take a full list of your population, pick a random place to start, and then you just select, say, every 10th person on the list. So if you've got a list of 2,000 nurses and you need a sample of 200, you just go down the list and pick every 10th name. It's super efficient and it's still random as long as your original list wasn't sorted in some sneaky, biased way.
But what if you need to make sure you have enough people from different groups? Like you absolutely need a good mix of ICU nurses, pediatric nurses, and ER nurses. Well, that's where stratified random sampling is perfect. First, you split your whole population into these important subgroups. They're called strata. Then you do a simple random sample inside each of those little groups. This way, you guarantee your final sample reflects the real-world diversity of the whole population. And finally, we have cluster sampling. Now this one is an absolute game changer when your population is spread all over the place, like across the whole country. Instead of trying to make a list of every single nurse, which would be impossible, you can just randomly pick, say, 20 hospitals. Those hospitals are your clusters. Then, you go and sample nurses from within those chosen hospitals. It's a super practical way to manage huge, spread-out studies. So that was the gold standard, the ideal world scenario. But let's be real. The real world of clinical research is messy. It's fast, and that gold standard just isn't always an option. And that brings us to our second path, the much more practical choice, non-probability sampling.
And this quote right here just nails it. Think about it. In a busy hospital, you can't just get a master list of every patient with a certain illness to randomly pick from. It doesn't work that way. You have to work with who you can get, who's available. So even though these methods aren't random, they are absolutely crucial for getting any research done in the real world. And just like before, there are a few common ways to do this. We're going to look at convenience, quota, purposive, and snowball sampling. Let's get into them.
Okay, the one you'll see most often, by a long shot, is convenience sampling. And it is exactly what it sounds like. Researchers just include people who are easy to get, the most convenient. Imagine a nurse researcher just surveying the patients on their own floor. It's super fast, it's cheap, but here's the big catch. There's a really high risk that this sample doesn't look like the patient population as a whole. It's biased. Quota sampling is kind of like a smarter version of convenience sampling. Here, a researcher sets targets, or quotas. They might say, okay, I need to make sure my sample is half men and half women. But, and this is the huge difference from the stratified random method, they fill those quotas by just grabbing the most convenient people. So it's not random. It's an attempt to make a convenience sample a little more representative.
Next up is purposive sampling. This is where the researcher basically turns into a detective. They use their professional judgment to handpick specific people who they think will have the best information. They're not trying to get a sample that looks like everybody. They are purposefully seeking out experts or people with unique experiences to get really deep, rich data.
And last for this section, we've got a really cool one, snowball sampling. This is what you use when you're trying to study a group that's really hard to find. You know, hidden or vulnerable populations, maybe people with a super rare condition. A researcher starts with just one or two people and then asks them to refer their friends or contacts who also fit the criteria. The sample just grows and grows, like a snowball rolling down a hill. It's brilliant.
Okay, so we've walked down both paths. One is all about the pure math of random chance, and the other is all about what's practical in the real world. So how do you choose? Let's tie this all together.
So here's the bottom line, the big trade-off. Probability sampling, because it's random, gives you results you can generalize to the whole population. It's got low bias, so it's awesome for big studies with lots of numbers. Non-probability sampling, on the other hand, isn't random, so you have to be really careful about generalizing. Its findings might only apply to that specific group. But it is absolutely essential for things like in-depth qualitative studies, for pilot testing ideas, and for all those times when randomization just isn't on the table. At the end of the day, it's not about one method being better than the other. There's no single best way to do it. The right choice always comes down to the research question itself. So here's my challenge to you. The next time you read a health study, flip to the methods section. Ask yourself two things. Who did they study, and how did they pick them? Because the answer to that question tells you pretty much everything you need to know about how much you can trust the results.